Okay, so here's how Gauss looked at the problem. So first, he drew a circle in the plane. X squared plus y squared equals z. Now, what's the normal equation you're used to for a circle with a center at 0, 0?
Well, x squared plus y squared is the radius. Right.
You sure? What do we usually say for a circle?
X squared plus y squared is the radius squared.
That's right. X squared plus y squared is the radius squared. Now, I'm following the book's notation. Unfortunately, they already called r something. They called that the function. R of n is the number of ways to write n as a sum of squares.
Yeah.
So I don't want to use r for the radius. I'm going to use z. So we usually have a radius squared here. So the radius of this circle is the square root of z. Okay, whatever the radius. So, but you see, we have, here's the point 0, 0.
Yep.
And that is the only point where the coordinates sum up to be 0. Here we have 1, 0, 0, 1, minus 1, 0, minus 1, and 0, minus 1. Those are the only points whose the squares of the coordinates add up to 1. Okay? Here's the point, let me start here. 1, 1, minus 1, 1, minus 1, minus 1, 1, minus 1. Those squares add up to what?
Those are the R of 2.
R of 2. There's 4 of them, just like you pointed out. Good thing you caught that, otherwise we'd have to go all the way back to the beginning now because there were 4 of them. Now here's the ones for 5. It was 2, 1, 1, 2, minus 1, 2, minus 2, 1, minus 2, minus 1, minus 1, minus 2, 1, minus 2, and 2, minus 1. And I skipped 4 here, but I wanted to show you where those 8 points were.
Yeah.
So what Gauss noticed is inside of this circle of radius z, square root of z, I mean?
Yeah.
That all these points actually represented the sum r of 0 plus r of 1 plus r of 2 plus all the way up to r of the square root of z, basically. Okay? Sorry, not the square root of z, r of z. Okay, so the number, so for example, if this was, let's say 1, 2, 3, let's say this was 4 out here.
Mm-hmm.
These points would be this would be the sum up to 16. And the radius would be 4.
Yeah.
So this would sum up to 16, okay? So it turned out that inside of the circle, the number of points is equal to the sum we're looking for. Now we want to divide this by z to get the average.
Yeah.
But he found a geometric way to understand this sum as the number of points inside a circle. Okay? So now came an incredibly interesting bit of intuition from Gauss. You ready for this?
Yeah.
Okay, let's move on to the next video.